Yeah. Welcome to this Fundamentals of Cybersecurity class. Today we are going to see about digital certificates. Okay, so what are all the things we are going to see in this lecture video are digital certificates, the definitions of the terminologies under digital certificates, why we have been going for this digital certificates and all. So we all know it is actually a common application of cryptography, and where we have been using these digital certificates in our daily life, we are going to see with a demo. And then the purpose, as I said earlier, the purpose of the digital certificates, and then knowing how we can manage these digital certificates as an administrator. And then what are all the types of digital certificates present here in this real world we are going to see. So the type, the purpose, and how we are going to manage the digital certificate. So these are the three things we are going to see in this video. So we all know, right? So it is a common application. Digital certificate is a common application of a cryptography. So we all know, right? So while writing a letter, we have been signing the letter, undersigning that letter, which means that we have been it seems that we have been authenticating that letter. So this is the letter I have written. So that is actually a conventional signatures. So in case of digital world, we have to see digital certificates and digital signature. Let us move into the next section of this video. So what is mean by digital signature first? So what is mean by digital signature first? It is actually used to prove a document originated from a valid sender. So as I said earlier, the conventional signature. So I am writing a letter, say for example, from myself, my name and the address, and to the, say for example, to the principal, to the address of that principal. So, and I'm writing that letter, and finally yours faithfully I'm signing that letter. So which means that this is called actually a conventional signature, which means that I am approving that letter, I am authenticating that letter, so telling that I am the owner of that particular information what I have written in that letter. So that is actually conventional signature. In case of digital signature, this for the digital data, we have to sign it in a digital form. So this is used for proving that particular document originated from that valid sender or not. So that is actually a digital certificate. So this is the picture view of a digital signature. Say for example, there is a sender and there is a receiver. Hello is the message where I am going to send to the receiver. So in the digital signature, this hello should be authenticated, which has been originated from a particular authenticate sender, right? So this has to be ensured here with the help of digital signature. So hello is the message. So it has to be received to the sender. It has to be received to the receiver. So telling that the digital signature will tell that, so this hello is a message which has been originated from the authenticated sender, right? So here we have been using a private key of the sender, and with the help of the private key I am going to encrypt this message. So this is the message. Say for example, we can use any algorithm, signing algorithm, encryption algorithm for encrypting this message. So, and at the receiver side, this encrypted message, the ciphertext will be received, and with the help of the public key I am going to do a decryption here, and the message has been received here as a hello. So this is how the digital signature procedure is happening in the cryptography. Okay. So what are all the weaknesses present in these digital signatures? So what are all the weaknesses? So every applications, it has its own weakness, it has its own vulnerability. So we have to find that weakness, and we have to, seal that weakness, seal that loophole. So what are the weakness of digital signatures? They only show the private key of the sender, right? The private key of the sender was used to encrypt the digital signature. So here, with the help of the digital signature, the private key is alone used for the encryption, encrypting the message what I am going to send. So only the private key is used. They only show the private key, right? So for the encryption. So that is the one kind of weakness. The second thing is imposter could post a public key under a sender's name. So yeah, there may be a MIM attack, right? MIM attack, man in middle attack may happen, right? So a imposter can use their public key, and they will do some man-in-middle attack, which will be explained in the next slide. So this is actually the imposter public key attack. So what is actually in this scenario is, say for example, a Bob using a public key. This is the public key, and he is sending a message by stock now. So this is the message which is sending, and it has to be received by the allies. So allies is the receiver, Bob is the sender. So here is the sender and here is the receiver. Okay, so say for example there is an attacker called Mallory. He intercepts the message and creates the imposter key. He intercepts whose message means the Bob's message, the sender's message. So he intercepts the message. He did some man-in-middle attack, and he intercepts this message by stock now. So he imposted a key, right? So Bob's uses a key called a public key called 2111984. So the attacker Mallory, he uses his own public key, right? So he intercepts the message of Bob's, and he changes this message into sell stock now. So the original message is buy stock now. He intercepts the message and he transfers the message into sell stock now. So with the help of the public key. So allies retrieves the imposter's public key, right? So he sends the message. He sends the message called sell stock now, and he imposted the public key 01071981 instead of 2111984. So 2111984 is the original public key of the sender box, and he intercepts the message. The attacker intercepts the message, and he removes this public key, and he imposted the hacker's public key, right? So allies retrieves the imposter public key, and he decrypts the message, and he got this message sell stock now, and he sell the stock instead of buying the stock. So this is called actually impostering the public key attack. Okay, so this is the weakness of the conventional digital signature. So let us get into the digital certificate. Why the digital certificate came into view while discussing the digital signature. So what does mean by digital certificates here? It is actually a trusted third party. This is used to help to solve the problem of verifying the identity, right? So it is used to verify the identity first, and also it verifies the owner, and also that the public key belongs to that particular owner. So in the previous slide, Bob uses a public key, but Mallory, who is an attacker, who removes that original public key of the original sender, and he imposted his own public key, right, along with the message. So while receiving at the receiver side, the original receiver receives the attacker's imposter public key. So to avoid this, I am going for a digital certificate here. It is actually the trusted third party application. It is actually a trusted third party concept. It is used to solve the problem of verifying the identity. So it is used to verify the owner, so who is actually sending that particular message, and also the public key belongs to that particular owner. It also verifies the public key which is belong to that particular verified owner. So it helps to prevent the man-in-middle attack that impersonates the owner of the public key. So this will be can be avoided with the help of this digital certificate, right? So preventing man-in-middle attack, what we have discussed in the previous slide, impersonating the owner of the public key, right? So we can prevent this man-in-middle attack, So digital certificate, what is digital certificate? This is the definition, a correct definition, a perfect definition for digital certificate. It is a technology used to associate a user's identity to a public key. So this has been digitally signed by a trusted third party. So digital certificate is a technology used to associate a user's identity, what we have discussed, right? So verifies the owner, and then the public key belongs to that particular verified owner. So associate a user's identity to a public key. So it has been digitally signed by a trusted third party, right? So here we have been overcoming the non-repudiation concept here. So what is mean by non-repudiation? You all know, right? Non-repudiation. You know, right? Non-repudiation means something you have been denying what they have actually did. So I am doing some actions. After doing that actions, I am denying that thing, means non-repudiation. Here we have been avoiding the non-repudiation here, right? So overcoming the non-repudiation with the help of digital certificates, with the help of the trusted third party. So if any common person is there, I couldn't deny, right? So if two person is communicating with each other, if I am telling some information to that particular person, say for example I am A, the opposite person is B, so I'm conveying some information to the B, and after conveying that information, if the B did some action based upon my information, I am telling after the actions, telling that I didn't tell anything, I didn't tell anything, I am denying that particular information, right? So that is actually non-repudiation. If a common person is there, say for example C is there, while the conversation between the A and B is going on, so I couldn't deny, right? So because C is the common person, so that common person is called here the trusted third party. Got my point? So that is actually called a trusted third party. So if a common person is there, I couldn't deny anything, right? So that is actually trusted third party. Okay, so what are the digital certificates it holds, right? So what are all the information it holds, digital certificates? So the what are the digital information it holds, right? So owner's name, owner's public key, issuer's name, issuer's digital signature, digital certificates, serial number, expiration date of the public key, everything it holds, right? So demo I will let you know in a separate video, right? So demo for digital certificates and the upcoming demo I will combine it with the combine, and I will do a separate video for this demo. Okay, fine. So managing the digital certificates, how we can manage this digital certificates? As you all know, digital certificate, it is actually it has been digitally signed, right? I'm providing a certificate for that, for verifying the owner and the holder of the public key. I mean, who is holding that public key, who is generating that public key, right? So that is what we are going to verify here, right? So yeah, for this I have to create the digital certificates. So I have to provide a digital certificate for each and every message what I am going to transfer or what I am going to hold, right? So for that I have to manage the digital certificates, right? So what are all the things, the components there for managing the digital certificates are certificate authority, registration authority, certificate repository. So these are all the three components that has been used for managing the digital certificates. Let us see one by one the certificate authority. It serves as a trusted third-party agency. So what I have told, right? So A and B is conveying some message. If I am denying, A is denying some message, denying some information that I didn't tell anything to that particular B. So I have to have some common person, that is called actually the C. That is actually the trusted third-party agency. So I couldn't deny something what I have conveyed earlier. What the message I have conveyed earlier, right? So that is actually here the third party agency. So it serves as a third party agency. So certificate authority, the C, what in our scenario is, the C is called actually certificate authority, who is actually serving as a trusted third party agency. It is responsible for issuing the digital certificates. So here A and B is communicating, right? So this is our scenario. A and B is communicating. If A is telling something to B, after that he is denying that I didn't tell anything, right? So if he is denying some information what he is actually conveyed with the B, then that is called actually non-repudiations we have seen. So C is a common person who is listening the communication between A and B. Right. So with the help of C, I'm here confirming that A is sending some information to B that he couldn't deny. So here C is act as a third party agency. He is responsible for issuing the digital certificates, right? So he is actually verifying that verifying the particular owner is transmitting the message, and he is creating the whose public key is actually right from the owner's verified owner. That's also he's been verified by the particular third party agency. So CA, certificate authority, be an internal or external to an organization. This is also I'm going to show as a demo at a separate video, right? So CA, certificate authority, can be internal or external to an organization. So what are all the duties of CA? he can generate, issue or distribute a public key certificate, distribute CA certificate, generate and publish the certificate status information. He can provide a means of subscriber to request a revocation, right? Revocation we will see in the next slides, the next further slides. Revoke the public key certificate. Sometimes we need to revoke some public key certificates. It will maintain the security, availability, continuity of the security, certificate issuance, signing functions. So everything are the duties of a certificate authority, right? Okay. So what is actually happening? Say for example, a subscriber requesting a digital certificate. Say for example, A and B is communicating with each other. A or B needs some requesting a digital certificate for the communication. So what CA will do? What CE will do is it generates the public key and private key. C is going to generate the public key, right, and the private key. So in the previous case, A is actually generating the public key and private key, but here with the help of the third party agency, I am going to generate the public and private key. So here is also that digital third party service is also generating the certificate signing request, CSR. Right? What does it mean by CSR? It is a specifically formatted encrypted message that validates the information the CA requires to issue the digital certificates. So CA, right? CA is about to, issuing the digital certificate. Before issuing the digital certificate, so it has to verify some information. So it will validate the information of A and B, and then finally it will issue the digital certificate. So CA inserts the public key into the certificate. So this is also the third step it will do. So CA, it will insert the public key into the certificate, right? So certificates are digitally signed with the private key of the issuing CA, right? So this is the final step, fourth step. The first step, it will generate the public key and private key. And then before sending the information, before encrypting the information, it will validate, right? With the help of CSR, it will validate the informations. And then finally, it will issue the digital certificate. After issuing the digital certificate, it will insert the public key into the certificate, right? So what it will actually generate, right? So it will generate a public key certificate, public key in the first step, right? So that generated public key will be inserted into the certificate. After that, the certificates are digitally signed. So after inserting the public key into the certificate, it will digitally signed with the private key of issuing CA. So who is issuing the CA? Right? We know, right? So who is issuing the CA? The private key of the issuing CAs, right? So certificates are digitally signed with the help of the private key of the issuing CA. Okay. So this is the 4 steps happening with the help of CA, Certificate Authority. So let us have some look into the CSR, certificate signing request. What are all the contents it has to be verified before issuing the digital certificate? So the name, right? So the name, company name, business name, department, right? City. So where it has been originated, the state, country, email address, everything it will validate. The information has been validated by the CSR, certificate signing request, before issuing the certificate. Right, the digital certificates are used extensively on the internet also, right? It has been used extensively on the internet also. Web browsers are pre-configured with the default list of CAs. Right, number of CAs are there, right? Though that default list of CAs are being pre-configured in the web browser itself. So list of CAs in the Chrome web browser I will show in a separate demo, right? Separate demo, or we can see in the live classes also. Okay, fine. So the second component for managing the digital certificate is the registration authority. It is actually the subordinate entity designed to handle a specific task of CA. CA's subordinate, we can consider RA as a CA as a subordinate to handling the specific task of CA. It will processing the certificate request and authenticating the users. So these are the duties of RA. It will process the certificate request and authenticating the users as well. Although the registration functions could be implemented directly with the CA, there are some advantages to using a separate RA, right? So anyhow, the registration functions are handling by the CA. Some advantages are there if I am having a separate RAs. If there are many entities that require a digital certificate, right? So this is the first scenario. Why we have to use a separate RA? If there are multiple entities that require digital certificates, I have to use a separate RA. If there are spread out across the geographical areas, instead of using a single centralized CA may create a bottlenecks, and hence I am using a separate RA here. Okay, so these are all the things and the duties of registration authority. Using one or more RAs, sometimes called as the local registrations, LRA, we can call it as a LRA, right? Local registration authorities who can offload this registration functions can create an improved workflow. So for a better workflow, we can have a local registration authority, right? So for improved workflow. Okay, so what are the general duties of RA? Similar to CA, we have to see the general duties of receive, authenticate, and process the certificate revocation requests. Right, identify and authenticate the subscribers. We have to identify and authenticate the subscribers, or even obtain a public key from the subscribers. Right, verify that subscriber possesses asymmetric private key corresponding to the public key submitted for the certification. So once before a person who want to send a data, so they have to submit their, the private key and public key. So that has to be verified. The digital certificate, right? In the digital certificate, the CA is actually generating the public and private key. So that has to be verified, right? So for this public key, this is the verified private key. So that has to be verified. So everything has been done by the RA. So the primary function of an RA will verify the identity of an individual, right? So this is the very primary function of an RA. So what are all the means? So what are all the way? What are all the path for a digital certificate requester to identify themselves to an RA? So what are all the things, how they can verify how this previous general duties of RA is happening through email. Insufficient for activities that must be very secure. The owner may identify only by an email address. So owner is only verified by the email address. Through an email, the RA will verify the owner, right? Although this type of digital certificates might be sufficient for a basic email communication, it is insufficient for other activities such as transferring money online and all. So and hence we can go for some other thing. Documents. An RA can confirm the authenticity of the person requesting the digital certificates by requiring specific documents such as a birth certificates or a copy of an employee badge, right? So this can be given as a proof, right, for issuing the digital certificate, right? So for verifying the digital certificate, for verifying the duties of RA and R. And then also we can do this verification in person also. In some instances, RA might require the applicant to apply in person to prove his existence, right? Who is going to, generate the digital certificates, and identity by providing the government issued passports or driver's license. So these are all the three means. It can be it can be verified, right, with the help of registration authority. And the third component is the certificate repository. This is publicly accessible centralized directory of digital certificates, can be used to view the certification status. Once the certification has been issued, so we have to view the status of the certificate. So this can be performed by the certificate authority, right? Regarding the status and all, it can be performed by the certificate authority. Can be managed locally also by setting up a storage area connected to the CA servers. This can be also done. So if I'm having some institution, I can create my own CA server, right? So I can create my own local server for verifying the certificates also. Right? So what it will do, certificate verification. There are a list of digital certificates that have been revoked. So what are all the certificates have to be revoked, which is being listed in the certification revocation component. So digital certificates normally have an expiration date such as 1 year from the date they have been issuing. So once the expiration date has been completed, it has to be revoked, right? It is a kind of renovation happening here. However, there are circumstances that may be cause for the certificate to be revoked before the expirations also. So what are all the conditions that has to be revoked? The certificate has to be revoked or to be renewed before the expiration date. So the reasons of certificate would be revoked. Certificate no longer used. So that is the first reason, right? Second reason is details of the certificates have changed, such as the user's identity like address and all. So this is the second reason why I have to revoke before the expiration date. The third reason is private key has been lost or exposed. Alright, so this may be also the reason why I have to revoke the certificate before the expiration date. Okay, so these are all the three things, a very important thing why I have to revoke the digital certificate before the expiration date. So what would happen if the digital certificates were stolen from the CA? So CA is actually, you know, right, CA, registration authority, certification authority is the first component, registration authority is the second component, and then the third component is the revocation component. So here, if any digital certificates were stolen from the CA, what is the next step we have to follow? So thieves could then issue the certificates to themselves that would be trusted by unsuspecting users. So for the unsuspecting users, the thieves could issue their certificates, right? So this is very dangerous actually. So it is important that the CA publishes approved certificates as well as the revoked certificates in a timely fashion. So to overcome this, CA should periodically send the certificates, right? Publish the certificates and revoked certificates, so that this kind of attack can be avoided. Otherwise, it would lead to situations in which the security may be compromised. So there is a stolen Google SSL certificate, right? So in a Dutch firm, right? So there is a link here. You can view this link, right? I will show this. I will display this link in the description of the video also, right? Okay. So there is a scenario. Okay, you can view this scenario. So what we have seen so far, we have seen that there are three components which has been used for managing the digital certificates. Okay, so digital certificates, it is actually a trusted third-party center that has been used for avoiding the non-repudiation, right? Okay. The current status of the certificate can be checked to determine if it has been revoked by two means. So how the revocation can be done? Certificate revocation list, CRL, it is the first method. The list of certificate serial numbers that have been revoked. So it consists of the list of certificate serial numbers that have been revoked recently. Many CAs, certification authorities, maintain an online CRL, certification revocation list, that can be queried by entering the certificate's serial number. So with the help of the serial number, I can query, right? So through online, I can query the CRL whether my certifications is being revoked or not. In addition, a local computer receives updates on the status of the certificates and maintains the local CRL also. We can maintain the local CRL also for revocation. Right, there is another process called online certification status protocol, OCSP. This is the second method for verifying the revocation. Performs a real-time lookup, right, of a certificate's status, it is also called as a request response protocol. So the browser sends the certificate information to a trusted entity known as the OCSP responder. The OCSP responder provides the immediate revocation information on that certificate. So this is happening on a real time, how the revocation list has been verified or not. So there is a process called OCSP stapling, online certificate status protocol stapling. It is where the web server sends queries to the OCSP responder server at regular intervals to receive the signed timestamp response, right? So this is called actually OCSP stapling. So we will explain this OCSP with the help of this figure. Say for example, the web server is actually starting the first step of this OCSP. Is this certificate is the valid? There is a OCSP responder is there, and he will respond, yes, it has been signed approval and it is approved, right? So in the third step, the browser want to connect, it will connect to that particular web server, and the web server based upon this verification, right, the step 1 and 2, it will send approval to the web browser. Maybe the client is communicating that particular web server, right? So it has to be approved. So here is the approval it will send. So it will not take care of verifying, the web server will not take care of verifying that particular certificate, right? Verifying the certificate revocation and all. So it has been done by some other thing that is called actually OCSP responder. Okay, so this is how the OCSP stabling is happening. So the time, the individual timestamp is being stamped with that revocation list and certificate, so that it has been verified during a period of time and all. So this is how the managing the digital certificate is happening. The next topic is types of digital certificates. So there are some categories of digital certificates that has been used for various purposes and all. So the most common categories are personal digital certificates, second one is server digital certificates, and then third one is software publisher digital certificates. So let us see the class 1 digital certificate, which is nothing but the personal digital certificate. It has been issued by an RA, registration authority, directly to the individuals, right? Frequently used to secure the email transactions. So this kind of digital certificates is being used for secure email transactions, right? Typically only require user's name and email address to receive. So for this kind of digital certificates, if I want to receive this digital certificates for my communications, only username and email address is more than enough for receiving this kind of digital certificates and all. Right, so what kind of purpose here it is used for securing the email transmissions and all. The second category is class 2 server digital certificates. So this has been used for the transmission of information between the browser and the client. Browser and the server. The client and the server, we can call it as a client and the server. This has been issued from a web server to a client. As I said earlier, this has been issued by a web server to a client. Say for example, if I am opening a browser and I am going for some website, it has to communicate with the web browser, web server, right? So that is the conventional thing. Opening a browser, if I am typing something, some address in that browser, which means that it is communicating a web server. So this transmission should be authenticated, and it should be a secured way. So for that, server digital signatures certificates has been issued. So it has been issued by that particular web server itself to the client, ensures the authenticity of the web server, ensures the authenticity of the cryptography connection to that particular web server. So whether it has been encrypted or not, whether the any man-in-middle attack is happening or that. So we can avoid such kind of attack with the help of this server digital certificates. So this is the types of digital certificates. Second category of digital certificates, server digital certificate. How the handshake is happening. So as I said earlier, a browser. Some address is being typed by the browser by the client. So hello client, hello is the first handshake happening. Cryptographic information is being transferred here. The second thing is the server is handshaking server hello. Algorithms are supported server digital certificate. It verifies and creates a pre-master key here, pre-master secret key here, and this key is being exchanged towards the web server, right? Pre-master key. Both at the web browser and the web server, they create their master key, master secret, and the session key for the entire session of communication. Right, so this is how the server digital certificate handshaking is happening here. So very simple. The client say hello and server say hello. Right, it will create its own pre-master key. It has been sent to this web server also. So based upon the pre-master key, it will create a master key and the session key. Here also it will create a master key and the session key. So based upon this keys, it will communicate. The browser and the server will communicate. So this is the type of digital certificate. You can view, right? So there is a padlock is there while opening a web browser, while accessing any websites, right? So that padlock, if you are clicking that padlock, and under that, if you are clicking the certificates, you can view the certificates and all for that particular, secured communications. Okay, so the next thing what we are going to see is the same thing. So this demo I will show you, right? I will show you in the in the next video. There is a concept called extended validation SSL certificate, EVSL. So this can be used for say for example e-commerce websites and all. So you search here, right? So EVSSL in browser. So it requires a more extensive verification of legitimacy of the business. So there is another SSL is there, right? So it has been used for e-commerce websites and all. Okay, so this this is the thing I want to show in a demo, right? So this is this is called actually the padlock icon, which is present in the address bar of any browser where you are going to access any web server and all. So if you are clicking that padlock, you can view the certificate informations and all. I will show in this different video. Class 3 is the digital certificate. This is called actually software publisher digital certificates. It is being provided by the software publisher. The purpose of issuing this kind of digital certificate is to verify the programs are secure and have not been tampered, right? So this is also I have shown in the previous class also, a demo I have shown. Anyhow, I will show a consolidated demo in another video also, or maybe in the next live class also. And so this is a kind of 509 digital certificates. This is a standard for the most widely accepted format of digital certificate. So this digital certificate following this standard can be written by any application follows the protocol X.509. So current version we have been using is version 3. Okay, version 3. So these are all the X509 structure, right? So it consists of serial number, issuing signature ID, right? Validity period, right? So number of informations are there for X509 digital certificate. So this structure is mostly we have been following currently. Okay, so I will show some demonstration related to this digital certificate in the next class or the next video. Thank you, one and all.